where we were getting the data not from the database but some other source system, and it was coming not in the form of a file but in the form of an XML message. So it was easier to deal with. We did not have to go through the process of making the message understandable for the compute node. But there comes time when the message is coming from the source in the form of a file. When the source is not a database, they usually send their data in the form of a file. So that flat file contains records, and those records need to be processed in a certain understandable format, which is a DFDL format for us, so that the compute node where we are creating the canonical message for the target, that compute node can understand the incoming message. So that parsing we are going to talk about today. So we are again going to take over a non-CDC interface only, with a slight change that this time we're not going to assume that the input is going to be in the XML format. It's going to rather be in a flat file. So let me open my EDI. Okay. So when it comes to interfaces where the message is coming in the form of a flat file, we have a certain concept called message models, which we create so that our message, which is coming in the form of a blob data, can be formatted into a DFDL understandable structure where there is a parent-child tag kind of attribution, which can be further, used in the compute node, and the compute node can, access through the XPath of the incoming message and tag the respective sources to the target fields. So it becomes basically, once you put the message model into the place, the blob also converts into an XML sort of structure. So the rest of the processing becomes similar to that of a CDC interface, where the incoming message was in XML formatted data, and the formation of the canonical message becomes very much similar to that we saw in the CDC interface. So to keep that part similar to the rest of the design, or the rest of the design formats we have been following so far, we use a message model so that the incoming file message also starts to resemble an XML model. So you see, as in contrast to a CDC interface, I don't really have any in my video right now, but if you refer to the previous trainings, you would see that there was an MQ input, there was the audit, and then inside the message flow, we would have a transformation node. But here you can see that in order to make the message understandable, the flat file message, to make it understandable for the compute node, we have put a reset content descriptor here. This particular node is just a construction node where we have given the reference to a message model. This message that you see here is basically a message model that is going to do all the parsing of the incoming file message and convert it into a DFDL formatted data. And I will, run the code and show you how the DFDL formatting transforms the data from a flat file into a understandable DFDL format. So before we delve into that, let me just give you a simple idea about how we create a message set. So in order to create a message set, what we do is, first of all, we start by creating a library. Let me give it a name as ABC test. And we create it as a static library and not a shared one. The reason I might have given you in the earlier sessions also, or somebody might have explained it to you, but I'll go through it again, that the reason why we create a static library is because when we create a static library and then we use that as we give a reference of this library into a flow that we are actually developing, then what happens is that when you send your code for deployment, you do not have to compress this library alongside and send it as a separate entity. It just, as soon as you give the reference to your main flow, when you give the reference of this library to your main flow, a copy of this library already gets attached to your flow. And when you create a compressed bar file of your code, this gets involved automatically. So you don't have to send two separate components, like one of the library and one of the flow. It just goes as a copy alongside as soon as you give a reference to the main code of this library. So I'm going to put it as a static library, and there's no dependency on the existing static libraries. I'm just going to finish. This is a fresh library that we are creating. Inside that library, I'm going to create the message set, which will be parsing the file data that I'm going to get. So the sample file, let me show you what sort of a sample file I'm going to use. So this is a test sample file that I created. There are, you can see that there is a certain kind of format repeating, that there is a record, every record is having two, you can say two elements which are separated by a comma. The end of line character is CRLF. Usually when you open a file in Notepad++, it's not having the end of line character visible. So you have to click here so that all the characters can be shown. Once you click, the end of line characters also become visible. So this test file that I have, it has 2 rows of data. So basically the rows of data is a recurring element, and you have 2 elements in each row. So you can understand that you will have to create a certain format where, you define the definition of one of the rows and you mark that as a recurring element so that this entire data can be read. So if the kind of data that I'm talking about is this. And there is an end of line character at the end of each of them, which is CRLF. So this is the input message that I'm going to pass. So in order to create a message model for it, I'm going to click on the new, which is being displayed under the new static library that I created. I go to message model, and then I select record oriented text. Then I go to next. One more thing, there might come cases where your data will be coming from mainframe sources. So it will be having hexadecimal data. And in that case, the message model is basically a COBOL copybook that will be provided to you from the client or the data mapper. So in that case, you're going to select the COBOL option. But since we are creating a parsing format for a data, which is a simple character, which is not having hexadecimal values, so we are going to select record oriented text. Now we go to next, and we select the second option, which is creating an empty DFDL schema and modify the existing schema, the created schema into your custom needs. And then you go to next. So your library is already present here, you see. The folder, you'll have to create a new folder structure here. So that folder gets created in the backend. So I'm going to name that also as ABC test. Best to keep the names as similar as possible. And DFDL schema file name also the same. And I'm going to finish. Takes a little time. Once the format is finished, you see this particular XSD popped up where there is nothing created. So I'll have to start the creation from scratch. So what happens is, first you do show all sections. What you do is, the message element that you see here is basically the entire parsing format that you're going to create. But before that, you need to create an individual component which can identify a certain recurring kind of format inside the file. So the recurring format inside our file is basically one row which has 2 elements and has a CRLF element at the end of it and a comma as a separator. So first of all, I'm going to create a complex element, which is going to be a single variable which defines a certain recurring element in the file. So I'm going to give it a name as ABC test only. So I'm going to add local elements to it. As soon as you add a local element, you can add like 2 local elements because you are going to create 2 elements inside it. Say one is A and the other is B. All right. The data type is going to be string. The minimum and maximum occurrence I've kept as 1 because they are going to occur only once inside a row. And the sequence element is going to have the separator by default as comma only. So it's good for us. If it was pipe delimited, I would have put pipe here. And whatever delimiter was present in the file, I would put that here. Otherwise, right now our separator is comma and it is already present there. And output new line is being identified as CRLF by default. So that is also in place. So I'm going to save this. Now this is the definition of a single element. Now when I look at the entire message has a recurring, recurring number of these singular elements. So I'm going to go to message. I'm going to create a message. I'm going to give it a name, ABC test message. It's going to be the topmost element under which multiple elements of ABC test will occur. In our case, it's supposed to show us 4 elements of ABC test, and each of them having the element A and B's value. Okay. So composite type will remain sequence. This is the way you see it. Just give it a name. So this sequence here, it has a separator comma. But in the case of our file, the separator of 2 rows is not comma, it's CRLF. So we are going to put CRLF here. Okay. And we are going to add a local element here. Now I give it a name as, say, ABC test only. And the data type here you see is string, right? So instead of giving it a string data type, you go down and you give it the data type of the complex element that you created. So now all the elements that are supposed to keep repeating, they have already come inside this, okay? And you put it as a max occurrence of unbounded because it's going to occur multiple times inside your message. So this defines the file format that you have just created, or the file format that you already have, and on the basis of that, you created this message set. Now let's just test it. You go to test path model, and let me just give you a very small heads up before you ever come across these things. Creating a message model is going to be more tedious than it appears. Like right now, I'm giving you the simplest possible example so that you don't get confused. But when you actually work upon creating a message set depending upon a file that comes from the source, because the file is not going to change, you just have to modify your message set accordingly. So you will face a lot of hurdles. And even if your message set appears logically appropriate to you, the file might give thousands of hurdles to you. So don't get disheartened, because even I have been in the project for so long. I have worked on numerous message sets, but maybe I am a slow learner or what. But this has given me a lot of problems. I mean, creating a message set does involve a lot of challenges. It does come with a lot of challenges. So it's never a problem, because you always have the option to test it and check where you got the exception. And once you get an exception, you can always go and check where your exception was and why it occurred. And depending upon that, you can modify your message set. So it's never going to, come straight the first time. It's going to take many attempts. But once you create it, you will be able to understand that this process, of creating a message set changes with the kind of message that you have. So I'm going to give you a very simple example so that, you don't get confused. Fortunately for you people, most of the file formats that we'll be handling, you will definitely have a certain interface where this particular logic has been implemented. So whenever you get stuck, you can always reach out to me or Shaila or Madhuri, or you can always go and refer our repository for a certain kind of interface which resembles the interface that you're working upon. And you can ask us whichever interface could resemble your requirement and also get help from us. So it won't be a problem, because, frankly speaking, before giving you this particular KT, I also worked on one of the test message creation, just to make sure that you don't, no exceptions pop up while we are having the KT. So if you face troubles while creating this, whoever has to create it in future, you don't get disheartened. Just keep working on it again and again. The test path model option, which you just saw here, is going to help you a lot to debug your entire message set that you created without running the entire code. So I'm going to select the message and click OK. So it's asking me if we can switch the perspective, like Madhuri had shown you earlier, that when we start debugging, it switches to a certain debug perspective from the integration development. Integration development is where you develop the code, and debug perspective is where you can see the see how actually the code is behaving when the input message has entered the code or the flow. And similarly, when I'm running this particular DFDL model, so it's going to switch to DFDL test perspective. So I'm going to do yes, so it switches, and the passing completed for the incoming message. So you can see your incoming message had 4 elements, 4 rows, each of them having 2 elements. So we have 4 rows passed into ABC test, and each of them has A and B. Okay, whatever data was present there, it has been parsed successfully. You can also have, this is a tree view, which is again good to understand. If you don't have, if you have a huge message set, then you can select this particular XML view and you can view that also. And we can try and show you that here. This particular thing, this language, So yeah, this is the XSD mode of the XSD that you have created. Obviously, it's going to appear as an XSD instead of coming as an XML simply. So you see the data type is present here, and the data length is also present here. In case where you have, there will also be cases where the delimiters are not present. Then you will have to define the length of the data that you are passing. I mean, just to give you a view of it, like this is the element A. You see that the length kind here is mentioned as delimited. When you don't have delimiters, then you are basically given message parsing logic by the data mapper. Like what length of the data corresponds to what particular field. I mean, it could be, for instance, what I'm talking about is your input message could be something like this. There is no delimiter. So what will happen is you will be told by the data mapper that the first three elements, like the first three length data corresponds to element A. Then the next three corresponds to element B. This is something that you'll be told by the data mapper itself. So in that case, what you do is you go to your this option called length kind. Instead of putting delimited here, because you don't have any delimiters here, you put explicit, and in explicit you have this length. So you, instead of having it unset, you put the length that you want. Okay. So for if A is 3 length, then it's going to be 3. And similarly for B also, you go and put length kind as delimited. Instead of delimited, you put explicit, and you add the length as 3. So that's how it's going to work. Right now, my entire message is as per a delimited format. So I'm just giving you an idea. If there was no delimiter, we would not be having this particular delimiter also. We'd be having this particular delimiter removed. Nothing would be here. And your A and B elements, instead of being a delimited, it will be explicit length of whatever length you identify. So it's going, this A is going to read the first 3 characters, and this B is going to read the next 3 characters. That's how it will go. So this I've shown you as an example. Now let's go and hit an actual board. So this particular store order interface that you see here, what it's doing is it's getting a file in the file input, whatever directory has been identified here. Like in my case, I was doing a local testing. So I've put an input directory which I could access in my local VDI. And after putting audit, one more important thing, like here you can see that there is audit, and then you go inside this particular thing. You put this reset content descriptor node. This is present in the construction palette. Here you see construction. Inside this, you have this content descriptor. So what it does, it just does nothing. It's a construction unit where you just can identify a message set. So store order message set has been put here, and that is why if I go and check the library reference of this particular one, it's going to show me as one is the audit library which has been referenced here. The other is store order message set. So if I open store order message set, this particular message is going to be there. The store order message is going to be there. Let me show you that. This is the store order message set. If I open the store order schema XSD, there is store order message set. You see here, this particular message has been referenced here. And in order to have that reference, I had to give a library reference on this particular application. Okay. When I go to manage library references, whatever application, whatever libraries I wanted to get referenced in my application, I selected them here. So store order message set was also required, and along with that, audit is always required whenever you develop a flow, because audits are a part of each and every interface that we develop. So here we have put a reset content descriptor, and we have defined a message set here, so that particular message set can be referenced here, and it's going to pass the incoming message. Okay. So I'm just going to do a deployment and show you how this particular thing works. Deploy it on the only PG that I have. And in order for you to be able to see how the message is going or, getting transformed while passing through the entire application, I will have to launch the debugger. And not just launching the debugger is sufficient. Once the debugger has been launched, I also have to put breakpoints wherever I want the message to halt and show me whatever is the value of the variable that got created at that point. So I put a, a breakpoint here. I right click and I put a breakpoint here. I get the option to remove because there's already a breakpoint present here. So what this breakpoint does is when the message enters the flow, I just get to know that there was no issue with the message coming inside. There was no exception thrown. And then I have a breakpoint inside this particular message flow, right? This particular message flow I open. And inside this, I'm having a breakpoint before message set, which has been defined in reset content descriptor, has passed, and after it has passed, so that I can do a comparison. I can show you the variable, how, where the incoming message is being stored and how it got transformed from one format to another. Okay. So I have launched the debugger. So what was the incoming input directory that I had identified here? It was this. This is the incoming directory. I need to put a message here. So I already have a file which, was of the source, which was provided by the source. Let me just check if this is the correct one. If that's the case, we can proceed. So, okay. So we have this particular file where the end of line characters are CRLF. Second, please. Let me see if the end of line characters are identified as CRLF only. I think the end of line characters for this particular interface were LF. Maybe the file I put is wrong. Okay, anyway, I'm going to change the end of line characters. I remember this because I've worked on this interface in the past. It is not supposed to have this particular end of line characters. I'm going to edit. I'm going to enter conversion and I'm going to change it to LF. So this is the input file originally that came from the source. So it has delimiter as 5. I'll also show you the message set separately, where you can see that the delimiter 5 has been identified in the place of that comma delimiter that I showed you in the library that I created. Okay. So this is my input message, and I'll be expecting 4 tags to get created. Let me also show you the message that I created for this one. This is the message set that we're going to use for this interface. So we have the store order main element. We have a store order detail element under it. The delimiter which has been identified here, this is the separator for every line, which is LF in our case. And in the store order detail, the delimiter has been identified as 5. Okay. Instead of comma, it's 5. And my data is LF, the separator between each of my data is LF. So that's why all of my elements will be having output new line as LF. Okay. So I can also show you a test path here. Let me show you that also. So if I put the input file, at least that way I'll also be confident that my message is working properly. To that particular file, I hope I'm not going too fast. If you feel that I'm going too fast, you can just stop me at any point and ask me questions. I'm going to select this file, click OK, and I hope that it works fine. Okay, so there came some errors. I think I must have done something wrong. One of the elements got parsed correctly. Not sure why this happened. History. Separator not found at 155. How much did it pass? Item order quantity warehouse. Maybe there is some issue with the kind of file that I'm using. I don't know. Maybe let me use some other file. Maybe I'm using some advanced version of this particular message set. Somebody must have done some modification, and now I'm kind of stuck with that one using the old file on it. Let me try this file. I'm kind of glad that these kind of errors are happening here because, that way you just get to know that these are going to come in your way also. I think I'm using an old file or maybe some issue with the kind of data that I'm using. Because it's not parsing the processing date. Okay, let me remove this element from here. Then it will work fine. because I think somebody did some update and I got it from the, the repository that we have, and I just imported it and it's not working because I had the old message with me. If I do that, does it work? Okay, all right. I had an old message. So that's why this message set that I imported from the repository was the latest message set, but the message that I was using to, test this particular one is an older message. So that's why I got some issue. It had a new element which was not, this message set was having a new element of processing timestamp, whose data was not present in the file that I was using. So I kind of got to know that when I use the test pass model option. So yeah, let me show you again with the smaller file that I was using. Where is the smaller file? Yeah, this is the smaller file that I was using, which had 4 records, right? So if I select this file, click on OK. I think 4 elements should get created. The data got parsed. So we saw that there were 4 elements. Where is the file? Yeah. So this was the file that I just parsed. So it had 4 rows, right? So as per my message set that I had created, 4 rows got created of store order details, wherein each and every element that I had identified got created depending upon the place where it found the delimiter. So if I randomly pick an element like load ID, the load ID has, what value does it have? This value I can only copy that and show you. Yeah. So it has this 1021, this value till 1021. This load ID is that value. So if I go and see in the file, this is the value, right? And similarly for the next value, which was identified as store order number. Okay, then we have corporation ID and division ID as 001 and 30. So we have 001 and 30. Let me go and check the 30, and then we have district ID as I1, then rogue as AIMT, and store ID as 0184. So we have similar I1, AIMT, and 0184. You can see how wherever it is finding that delimiter, it is creating a new element. That's how the message model is working. So now the message that was a flat file, now it's a message of this particular type. Put it out here for you. So if I select it, it comes a message of XML format, which is having store order details, 4 elements of store order detail under store order, where all the elements have been created depending wherever the message set found the delimiter, pipe delimiter. Okay, so now I showed you the message model also. I'm going to show you a run of the actual flow. So I had launched a debugger and I had put debug points here. So the same message model has been identified in this reset content descriptor, has been configured here. So if I put this particular breakpoint here and I try to put the message in the incoming location which I had identified, which was this one. So my message, as soon as I put it here, it should get picked. Soon enough, the message got picked, and as soon as it got picked, it's asking me to switch to debug perspective because the message has entered the flow, and since I'm in debugging mode, so the debugging has started because the message has entered the flow. So it has entered from the file input node, crossed the audit, and if I click on this F8, which is resume, it goes to the next breakpoint directly. So I have reached here. So let me just show you the incoming message. It's of blob format, okay? And this is the data. This is the blob data which I have. So once it crosses the reset content descriptor, you see the data type changed from blob to DFDL. It has become DFDL now, and it has store order. Under that, it has 4 store order detail elements. So it is similar to the row set and row kind of data that we were getting from the CDC interface or the XML formatted data which we were getting yesterday in the XML provided from the source kind of interface. So this is again, this now, our further design becomes similar to that of the CDC interface because your input is, instead of being in XML-SC, it's a DFDL formatted data, but the entire structure of the you can say the incoming message has become analogous to that of an XML formatted data. So if I go inside the CMM transformation, let me also show you what the, how this particular thing is working. Let me show you that in normal mode instead of going to debugger. Okay. So as we can see, this is the where we have written the entire logic to create the output canonical message. So we have the namespace just as before. You see the incoming message has been given a certain kind of, references. So this reference variable which has been created, instead of having it as input root.xml and sc dot something, we have input root.dfdl and other references which we were going to use frequently, we have put them also. Okay. There is this exit handler to again capture exceptions and let the processing go smoothly for the rest of the messages which don't have exceptions. Then we have the document ID creation and everything, which is again referring to the mapping document. It is same as that. And yeah, as I had shown you earlier also, that when we get the data from a non-database kind of source, we usually require the need to, run queries inside our eSQL compute node. So here you can see that we have run a query and populated that value into this environment variable.batch variable. And once this query is run, you can see that this query contains, certain question marks here or somewhere. So what these question marks they do is basically when in this query, when you want to put a value that is coming into the eSQL into this query, what you do is you use a pass-through function and you define the entire query. And whatever data you need from the values that are coming in the compute node, you put a question mark there. Okay, like there are 4 question marks, 1, 2, 3, and 4. So similarly, in the same sequence, we have written the variables which have come into the eSQL, and those variables will be populated in the place of those question marks in the same serial order. So in the first question mark, you will be having corporation ID, then here you will have division ID, then you will have store ID, and here you will have corporate item code. Okay. So these values have been identified here, and they are coming in the execution. When your input message is getting executed, then only these values are coming, and they are getting populated into the query, and then this query is running over the tables whose join has been performed in the query itself. And whatever data comes from the query into the environment variable.batch, you can see it is getting populated into like address line 1 text we were getting. I'll show you Control-Shift-K. We were getting address line text. So this is getting populated here in the address line text, which is going to be a part of the output canonical. So we are setting the value in the output canonical from the input value, which is coming from the database for the address line text. Similarly for the rest of the fields also. Okay. Rest of the mappings, again, they depend on the mapping document which has been provided to you, which will be provided to you. There is casting, a similar kind of casting that we might have seen in the past. This particular casting is of the input message into a timestamp format, and this format that we've written here across the source message resembles the format of the source incoming data. Okay, so whatever data is incoming here, it was of this particular format. I mean, it was of this format where whatever data was the first 4 characters was to be identified as year. Then there must have been a hyphen in the data. Then there was these 2 characters which were supposed to be identified as date, month, and then there was a hyphen, and then there was date. The next 2 characters would be date. Similarly, there would be a space in the data, so we left a space here. Then whatever data came after the space was supposed to be identified as hour, that too 24-hour format, then minute, and then seconds. And the colons would be in between in the data itself. So this is the timestamp format that we were getting. So that's why we have put the source format so that we can identify that whatever, like we can understand what all data from the source is going to be identified as what type of data for the timestamp. So then we can convert it into timestamp using this particular casting. So now whatever will be stored in this output variable store date in the canonical, it will be of timestamp format and not of this particular format that you see here. Okay. And that to the timestamp format which is identified by IID. So we have similarly similar transformations going on. Few of the transformations have been commented out because maybe when later there was some work performed on the code, maybe those transformations were not required in the update of the interface, so they have been removed. And we have similar transformations. There are certain fields which are being created again and again. So we have a while loop for it. And we are running the query inside that also. Again, something that depends upon the requirement, which is outlined in the mapping document. This particular function you see here, this if exist function, again, requirement-based implementation, where if these particular fields or even one of them exists, only then we are going to create these tags in the output variable. If they're not present there, we won't be creating them. Similarly, I guess there's nothing new to show you. Then we move to the next element and so on till the recurring element has been created. Once the canonical is done, we are going to set an environment code variable, which is again going to be a part of the output canonical, and we propagate to the out. Once the propagation has been done, we set the CMM count, and once the canonicals have been created, we are going to set the list data variable so that the audit can be generated. And the audit is going to contain the number of canonicals that has been generated through a single input message. And then we propagate that audit to the out terminal. And then once the entire message has been processed from the source to the target side, then we have this environment, this exception throwing code, which is going to throw the exception for all the records that fail. So this is the code here, and this is how we have applied the transformation. So the application of the transformation was not very different from that of CDC interface, and that was only possible because of the creation of the message set, which converted the flat file data into a delimited format or a DFDL format. Okay. One more thing that you will be, starting to work with, whoever is going to do the development. The thing is that you just saw that I had a reset content descriptor inside this subflow where our message set was given a reference to. But from now onwards, we are going to reduce this particular node into the file input itself. So you go to the file input and you go to the input message parsing. Instead of having blob here, you are going to select DFDL. And as soon as you select DFDL, you are supposed to put a message here. So you go browse for the message set that you have put in the reset content descriptor. You select it and you put OK. So now what will happen is whatever incoming file you had, you won't be having any blob format in your incoming message. You will directly have the DFDL formatted data here. So, from this point onwards only, from the first node itself, you will be having your input file formatted into a DFDL format, and you would not have to wait till reaching the reset content descriptor to do so. This particular change has been identified and suggested to us by a designer with whom we're not working anymore, but she had a suggestion, so she gave it to us, and I think that is kind of appropriate, because unless you have a certain requirement where you don't need to, you kind of need to audit the input file as it is, or some other implementation where you need to, have a separate reset content descriptor and then, do some other transformation before it goes into the compute node. We don't really need a reset content descriptor node. We can do whatever it was doing here in the file input node itself. So we'll be taking this in in consideration from the development of, from the standpoint of developing the new interfaces. And that's why we are going to put the message domain DFDL here itself. Now, since it's the old one, so I'm going to change it back to whatever it was, which is blob. So the message format thing is on. Yeah, I think this is all I wanted to explain today. I think the rest of the nodes you guys are already familiar with, but if you have any questions, you can go ahead and ask.
Yeah,
Hello?
hi Pratyasha, Kanika here.
Yeah, go ahead.
Yeah, in the message set you showed the complex type, right? So that complex type, do we need to create every time, or it is based on the requirement? Like if the message is repeating, then only we have to create that.
See, most of the times, whenever you get a file, there must be a certain kind of, structure which will be repeating inside the file. So whatever that elementary structure is, which is repeating inside the file, you always create that particular structure in the complex variable category, so that you can then, recall that variable when you're creating the entire message. When you create the message set, there you need a certain variable which would be identified as a recurring variable. So that variable must be independently defined somewhere. It's like, creating a function, a recurring function. So you first, write the definition of the entire function elsewhere, and then you call it as an independent entity, however many times that you need inside the main program. It's like that. I hope it makes some sense.
Okay, so it is a good practice to create that every time, right?
Not just a good practice, it is basically the only method that we have.
Okay. Okay.
Yeah.
Pratyasha, there is another thing on the same point. The name which you gave over there. So like we will be receiving it from the data mapper, or we can like define ourselves.
You can define it yourself, because it gets created inside the application and it gets dissolved inside the application itself. Because the target will never get to know how you transform the incoming file. So since that it is not something that concerns them, so whatever nomenclature you use here, that's your call.
Okay.
Any other questions? Any other doubts? If you want me to show you certain things again, I can do that. If not, then I think over to you, Atul. Nothing else for today.
Hello, can you guys hear me?
Yeah, you're audible.
Okay. Yeah, it was a great session, Pratyasha. Thank you. Yeah,
Thank you.
if no one has any questions, I believe we can wrap up. Okay, guys. Thank you. Thanks a lot.
Thank you all.
Thank you. Thank you.